Good morning. My name is Karti Mayaram, and I'll be talking about the edge node or the sensor node and research related to that. And this is a project or research that I'm collaborating with Terry on. So I'll start out with an application that we looked at with these edge nodes or sensor nodes. And the application has to do with sensing temperature in a forest environment. And this was joint work in collaboration with the College of Forestry. And the idea was to distribute sensors within the forest, and the sensors communicate wirelessly with each other and to a base station. And the idea is the sensors take the temperature measurement and they send it to the base station where the data is collected and then the data analytics is performed on that. So when we started looking at this project, we started looking at building integrated circuits. And the work we've done here is an IC that includes the transmitter, the receiver. It also includes some digital control and also passive energy harvesting. If you're deploying sensors in a forest setting, you don't want to be going and changing batteries every 2 days. And the passive energy harvesting allows you to keep these sensors running forever, theoretically. In this particular example, we were using RF energy harvesting. So the base station was sending out radiating radio waves, and the sensors themselves were converting those radio waves into DC power that could be used for sensing and communication. And when we did this work, we had the lowest link per energy per bit sensor node at 2.4 gigahertz. In terms of energy harvesting, we've looked at other sources of energy. RF I've already mentioned. We've looked at solar, vibration, and temperature gradients also. And one of the things that we are doing with these sensor node applications is that we are not tying ourselves to a particular standard. So this is, in the forest setting, we were able to establish our own standard. And going forward, we think we have the flexibility in working with other standards. We are not committed to a particular standard. The applications that we are working on are smart homes and buildings. And the idea in buildings is that if you have old buildings and you want to retrofit those buildings with sensors, you don't want to run wiring, so the wireless sensors are going to be an important part of that whole aspect. Wearables and healthcare, I think health and wellness, as Terry has mentioned earlier, telemedicine and healthcare are going to be important areas where some of this work can be applied to. Thank you.